All right. Hopefully today we're going to get to solving larger polynomial equations. So for example, if I gave you a polynomial like this, we're going to figure out how to break that equation down to find out the smallest constituent parts. We're going to get to a point where, since the degree is 3, we know we have to have 3 intercepts. We're going to figure out these answers. But first, before we get that far, we have to learn how to crawl. This is our goal for today. We're going to discuss long division, synthetic division, the remainder theorem, and the factor theorem. All of those help us to cut these things up into the smallest pieces. But first, let's begin with something we know already. Let's look at that equation. If we factor this, what would we get? It'd be x's. What signs?
Both positive.
Yeah, they're both the same. They're both positive. What times what is 6? When you add them, you get 5. 3 and 2. So now what we're going to do, we're going to learn how to take these and we're going to test them to see if they're true factors, if they're true solutions. There are a couple of ways we can do that. One's by the remainder theorem. One of them is by the factor theorem. So let's look at this. Do y'all remember what long division was?
Yeah, but not really.
If I had 27 divided by 3, that could be rewritten as this. The denominator is called the divisor. The top number, or the number inside this thing, is called the dividend. The answer we get on top here is called the quotient. And whatever we end up with here at the last step is called the remainder. Those are the pieces of it. And when we put them together, we're gonna figure out if it works or not, if it's a good factor or not. So let's look at this. How many times does 3 go into 27? Let's try. So if we put in 9 times 3 is 27. What do we do next? We subtract. So we subtract the 2. 27 minus 27 is 0. That's your remainder. It works the same way with polynomials. So since the remainder is 0, we can say that 3 is a factor of 27. Because 27 breaks down to what? 9 times 3, 3 times 3. So the factors of 27 are 3 times 3 times 3. Because the remainder is 0, we know that 3 is a factor. In a nutshell, that is the remainder theorem. Let's see how it works for polynomials. We're going to look at the same example here. So we have x squared plus 5x plus 6 divided by x plus 3. So the first thing we have to do, we have to write it in long division form. X squared plus 5x plus 6. When you do long division, you always look at the leading terms. What times x gives me x squared? X, so just an x. So now we check it. X times x is x squared. X times positive 3 is positive 3x. So far, so good? Because remember, same as we did this one, we took 9 times 3 and put it down here. Now, since we have 2 parts here, we take what we put up here and multiply it to both of them. And put them, yeah, because everything here has to get multiplied to it. So x times x is x squared, x times 3. Now we have to subtract. When you subtract, that means you change their signs. When you subtract, you obviously it used to be positive 27. When I subtract, I change it to negative 27. So since I have 2 parts, I got to change both of their signs. And now you add x squared minus x squared, cancel. That has to happen. If the first term doesn't cancel, you did something wrong. Then 5 minus 3 is 2x. Bring down what you have left. Repeat the process. Look at the leading terms. What times x gives me 2x? Yes, it's a positive 2, right? So we have to put a positive 2. What do we do with this 2? We multiply to both of those. So 2 times x is 2x. 2 times 3 is positive 6. Next step, change their signs. Because I'm subtracting. The first term better cancel. 6 minus 6 is 0. There's my remainder. Since it's 0, what does it tell me? That tells me that x plus 3 is a factor of x squared plus 5x plus 6. And the other factor is x plus 2. Sure enough, that's what we got here. It's just that straightforward. Let's try another one. Pick another one. Let's do a bigger one. Let's say x cubed plus 2x squared minus 5x minus 6. Do it with all three of these to see which one of these or which ones of those are actual factors of this equation. So let's try the first one. So we have x plus 1 goes into x cubed plus 2x squared minus 5x minus 6. So we look at what? Look at the leading terms. What times x gives me x cubed?
X squared.
X squared. Actually, you sound like you were asking, but here's how you test it. If I go x squared times x cubed. If these two guys don't cancel, then I did it wrong. So I multiply it to both of these. X squared times x is x cubed. X squared times 1 is positive x squared. Then I got to do what? Subtract. So change your signs. X cubes cancel. So 2 minus 1 is 1x squared. Bring down everything else. Repeat the process. What times x gives me x squared? Positive or negative? So it's a positive x. So x times x is x squared. X times 1 is positive 1x. Got to change the signs and add. So negative 5x minus 1 is negative 6x. Bring down the negative 6. Repeat the process. What times x gives me negative 6x? So it's a negative 6. So negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. Change the signs. Now add. Negative 6, 6 cancel, 6, 6 cancel. So since the remainder is 0, that means x plus 1 is a factor. Here's the beautiful thing. Remember, we started off with this big third order equation. We know one of the factors is x plus 1. We don't have to go back to here. We can now factor this one. Because how many is this? How many answers do we need more? There's 1, we need 3. This will give us 2 more. So if we factor this one, what do we get? So x and x. This one says they're opposite signs. The bigger number is positive. What times what is 6 when you subtract them, you get 1? What times what is 6 when you subtract them, you get 1? Only, how many possibilities? Give me some numbers that equal 6 when you multiply them. 2 times 3, 3 times 6 times 1. So we have 3 and 2. So 3 is bigger. 3 times 2 is 6. 3 minus 2 is 1. So we just found all 3 factors of this big equation here. X plus 1, x plus 3, x minus 2. Whenever you get a remainder of 0, don't go back to the original, go back to the quotient and fix and start from there. So each time you find an answer, it gets smaller and smaller and smaller. All right, So let's see what happens if I did this one into this equation. X minus 3 into that big one. Okay. What goes in the first spot? X squared. What times x gives me x cubed? X squared. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Change the signs and add, because these two cancel. Positive 2, positive 3 is positive 5x squared, and bring down everything else. What times x gives me 5x squared? Yeah, positive 5x. So 5x times x is positive 5x squared. Positive 5 times negative 3 is negative 15x. Change their signs and add. 15 minus 5 is 10 minus 6. What times x gives me 10x? Positive 10. Because the signs are important. Remember last time we had that negative 6? You have to put them, make sure. So since this is a positive 10, you have to put a positive 10 up here. So 10 times x is 10x. 10 times negative 3 is negative 30. Change the signs and add. 30 minus 6 is 24. So it tells us that x minus 3 is not a factor. Of our polynomial. So far, so good. Now, here's something even more cool. In one of the first ones we did, let's see, x squared plus 5x plus 6. This is my function. And I want to divide it by x plus 3. This is the first one that we did. Another way we can do this. This is actually the remainder theorem. Whatever your denominator is, set it equal to 0. And solve for x. Okay. Now, if we take this x and put it inside here and work it out. Let's see what happens. So negative 3 squared is 9. Negative 5 times positive times negative is a negative. 5 times 3 is 15 plus 6. 9 plus 6 is 15. Minus 15 equals 0. What it says is if we have a function and we test it on a polynomial f minus c, solve this, we get x equals c. If f at c equals 0, then x minus c is a factor. What all that says is this: when you get your denominator, set it equal to 0 and plug that into the function. If the answer is 0, then you have a factor. Let's look at the next one we tried. This is f of x. X cubed plus 2x squared minus 5x minus 6. Remember, I said, let's try these questions. Let's divide them by these. Let's call this one A and this one B. So in A, if we solve it, what do we get? What does x equal if we solve it? Right. So let's try f of -1. -1 cubed, 2 times -1 squared, 5 times -1 minus 6. -1 cubed is -1. -1 squared is 1 times 2 is 2. Negative times negative is positive. 5 times 1 is 5 minus 6.
Wait, don't we have to cube 2? No.
Well, -1 cubed, since it's cubed, the answer is negative. 1 times 1 times 1 is 1. -1 squared is positive.
Oh, you did that.
You square, yeah, you square these first, so you do the powers first, and then you multiply by the coefficient. So -1 minus 6 is -7. 2 plus 5 is 7. -7 plus 7 is 0. So the remainder is 0. This is the remainder. So in other words, what it tells me is this: since that's 0, it tells me x equals -1 is an answer. Set this equal to 0. So this is your factor. That means the factor x plus 1 is a 0. So x plus 1 is a factor of this equation, because when I put in -1, I got 0. You see how all this stuff works? So it's now making it, now we're making the numbers equation smaller. But the bad thing about that is what? As opposed to the division method. All we know that x plus 1 is a factor. Now, the next time we try another number, we still have to go back to the original one. With long division, once we got a 0, we're done with the big one. We go what's on top, the quotient now. So that's the benefit of doing the long division, but this way is faster. This way is much faster. What you can do is, if you get a 0 here, go ahead and put it in this form and then do long division to see what you're left with. Let's do with this one. So if we have x minus 3, what does x equal? 3. So if we plugged in 3 inside there, we got 3 cubed plus 2 times 3 squared 5 times 3 minus 6. 3 times 3 times 3 is 27. 3 squared is 9. 9 times 2 is 18. 5 times 3 is 15. Minus 6. 27 plus 18 is 45. 15 plus 6 is 21. 45 minus 21 is 24. It was our remainder when x minus 3 was used. Pretty cool. I mean, think of it now. Now we have tools that we can use to start solving these bigger equations. If we can get the right combination of them and the remainder is 0, then we know we have a factor. And we just have to keep on going this many number of times till we find 3 of them. So in other words, I can also ask you this. If f of x equals 4x cubed minus 3x squared plus x plus 7 is 2 a subfactor? No, if this is, see if this works. See what happens if you plug it in the equation. And then if it does equal 0, then we'll ask you what the factor is. Yeah, and this point here, I don't mind if you use calculators, because I know you guys can do the work. It's just that it's drawn out now. It's just basic numbers. So I don't mind if you use calculators on this part. Yeah, so 2 cubed is 8, 2 squared is 4. 4 times 8 is 32. Minus 3 times 4 is 12. Plus 9. 32 minus 12 is 20. So what can you tell me about that number 2?
It's minus 2 is not a factor.
Yeah, so it says 2 is not a 0 of the polynomial. And then x minus 2 is not a factor of the function. So this one, we're looking at, is it a 0? No. If that's not a 0, then the same reasoning, that's not a factor. Let's try another one. G of x equals 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8. Try G of 2 now.
I'm gonna do, long division on this one.
I'm going to show you a shortcut in a second too. Actually, I'm glad you said that. We'll try it just for practice. You'll appreciate the next thing I'm going to show you afterwards anyway then. So we have 2 to the 5th minus 3, 2 to the 4th, 2 to the 3rd, 2 times 2 squared, plus 2 minus 8. You get tired just writing it. What is 2 to the 5th?
Eight, 16.
32.
Huh? How you get 32 so fast?
2, 4, 8, 16, 32.
That's only 4 times, right?
2, 4, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32.
Oh, okay.
2 to the 4th. 16. 2 to the 3rd. 2 squared. 2. (32) times 2 is 64. 16 times 3 is 48. 4 times 2 is 8. All right, we know that -8 and +8 cancel. 2 plus 64 is 66. -48 plus 8 is -40. (26). That's outrageously big. I mean, a big equation. No, I see. Are you okay with synthetic division? I mean, with long division?
Yeah, let's not do it.
Are you okay with it? Or you want to try it?
All right.
That's for practice. I mean, I'd like to make sure you all know it. So what we have here is x minus 2, 2x to the 5th, 3x to the 4th, plus x cubed, 2x squared, plus x minus 8. I mean, even typing that in the calculator would be arduous. So what times x gives me 2x to the 5th?
2 to the 4th, right?
2x to the 4th. So 2x to the 4th times x is 2x to the 5th. 2 times -2 is -4, x to the 4th. Change the signs and add. 4 minus 3 is 1, x to the 4th, and bring everything else down. It's a lot easier if you do the work too, instead of watching me.
Well, I do.
Okay, that's true. It'll be on the video. You watch it again. Yeah. So what times x gives me positive x to the 4th? Positive x cubed. Also notice up here that the powers are decreasing as these are decreasing. X cubed times x is x to the 4th. X times -2 is -2x cubed. Change the signs. Add. 2 plus 1 is 3. Bring everything else down. What's my next number? Yeah, 3x squared, because what times x gives me 3x cubed? Positive 3x squared. 3x squared times x is 3x cubed. 3x squared times -2 is -6x squared. Change the signs. Add. 6 minus 2 is 4. What times x gives me 4x squared? Positive 4x. 4x times x is 4x squared. 4 times -2 is -8x. Change the signs and add. 8 plus 1 is 9. Minus 8. What times x is 9x? Positive 9. 9 times x is 9x. 9 times -2 is -18. So change the signs.
You can tell Rob.
X minus 2. Did I change the sign somewhere? So it's 2 minus 3 plus x minus plus minus. That's plus. X cubed. Plus 6x squared. Four. 8. Okay, then possibly made a mistake on this side. 2 times 32 is 64. 48 plus 8 plus 8 plus 2 minus 8. That's where I messed up right here. It should be a negative. So this 8 and that 8 should cancel. Yeah, so we should have minus 48 minus 8. So it's 66 minus 56, which is 10. So you see, at least this way it's a good check. But that's a long way. There's a faster way. Even faster than this, plugging number in. It's called synthetic division. Synthetic division. It only works if the denominator is of the form x plus or minus some number. In other words, the x on the bottom cannot have a coefficient or an exponent or anything. It only works, okay, so we had this example. And we want to divide it by x minus 2. In synthetic, I'm sorry, you want to finish? Okay, I thought. So in synthetic division, we don't deal with letters anymore, only numbers. Let me find some other examples here. All right. Because we'll go back to the original one we did earlier. With the denominator, take this, set it equal to 0, and whatever your solution is on the denominator, that goes on the outside. Synthetic division, now, you know you're using synthetic division because now it's upside down. And we only use the coefficients. So for the first one, it's 2. Then -3, +1, -2, +1, -8. Remember all the space that long division took? This is all the space it's going to take.
Wait, isn't it negative one?
Sure. Is it -1?
I don't know. Never mind. That's what it was.
No, +1. All right. Synthetic division is a process of multiplying and adding. That's it. So our first step, bring the first number down. The number that ends up here is your remainder. Now we multiply this number times this. 2 times 2 goes here. Add straight down. 4 minus 3 is 1. Can you guess the next step? 2 times 1 is 2. Add straight down. 2 plus 1 is 3. 2 times 3 is 6. 6 minus 2 is 4. 2 times 4 is 8. Add straight down. 8 plus 1 is 9. 2 times 9 is 18. 18 minus much faster. Let's look at some other ones that we did earlier. Oh. Let's look at the first one we did. X squared plus 5x plus 6, x plus 3. Can we do synthetic division here? Yeah, because the bottom is x plus or minus a number. So how do you set it up? Set the bottom equal to 0, which means x is equal to -3. What numbers go inside here?
1, 5, 6.
Right, there's just the coefficients. To help you make sure, because if one of these letters are missing, so I start, this, the highest is x squared. So that's the coefficient. Then it's x, then it's the constant. Because when you have longer ones, you may have pieces missing. You have to allocate those columns there. Bring the first one down. And begin your process. -3 times 1 is -3. Add straight down. 5 minus 3 is 2. -3 times 2 is -6. The remainder is 0. So since the remainder is 0, it says that this is a factor. And here's one more thing it does. This is the other factor. That's the constant. That's the x. So there's our answer. Much easier. Let's see when. Let's look at that bigger one that we know works. Let's look at this one. X cubed plus 2x squared minus 5x minus 6 divided by x plus 1. Yeah, it's always the opposite of sign. Just the coefficients. This is x cubed coefficient, this is x squared, this is x, and this is the constant. What do I do first? Bring it down. What goes here? Yeah, -1 times 1 is -1. 2 minus 1 is 1. -1 times 1 is -1. -5 minus 1 is -6. -1 times -6 is +6. The remainder is 0. So we know that x plus 1 is a factor. And here's the other factor. That's all we have to go. Because now the constant is 6. The coefficient of x is 1. And this one is x squared. It keeps on building up from there. So we can factor this one out next. X plus 3, x minus 2. So once you find a 0 remainder, just look what's left. And it builds up from there. Which is what the factor theorem tells us. If your remainder is 0, then whatever the denominator is a factor. Let's look for an uglier one. No, we did that one. Oh, that's what I want to do. With what we know so far, take this polynomial. With what we know so far, try to see if you can factor this one out. How would you go about doing that? What method are you going to use? Synthetic division, long division? Well, what would be the logical way to approach this would be what? Is x plus 1 a factor? Is x minus 1 a factor? Is x plus 2 a factor? Is x minus 2 a factor? So if we use synthetic division, what would we put instead of this one? Let's try -1. So it's 1, -3, -6, and 8. We're looking for a 0 here. So bring down the first one. -1 times 1 is -1. -3 plus -1 is -4. -1 times -4 is +4. -6 plus 4 is -2. -1 times -2 is 2, is 10. So that doesn't work. Let's try the next one. Let's try with 1. 1, -3, -6, 8. One times 1 is 1. So what? This says that it's this factor. So out of this equation, we know what is a factor. That equals 1, but what does that come from? So we know, yes. So we know that this, one of the factors is x minus 1. That one there. Now, let's look at this one. This is -8. 2x, -2x, x squared. Can we factor that one out? Since it's a quadratic, we can use a quadratic formula even. X and x, negative, so it's opposite signs. The bigger number gets a negative. What times what is 4 when you subtract them, you get 2. 4 and 2. So these are your factors. You now found the x-intercepts. The x-intercepts are at 1, -2, +4. And we know the y-intercept is at 8. We know since it's a cubic function, the graph looks like this. So we know the intercepts are going to be at -2, 1, and 4. Pretty cool. Okay, let's do another one. F of x is equal to x cubed plus 2x squared minus 5x minus 6. Factor that one out. Okay, yeah, so let's start off with x plus 1, x minus 1, x plus 2, x minus 2, and so on and so forth. So this one would use -1. X coefficient of x cubed, x squared, x, and negative. Bring the first one down. -1 times 1 is -1. 2 minus 1 is 1. -1 is -6. So the first one is x plus 1. That's the first factor. So now we just have to look at this. X squared plus x minus 6. Notice, because we're dividing by x plus because of x, we lose one exponent. From the original equation to this last one, we lose one. So now we just have to factor this one out. Opposite signs. 3 and 2, because what times what is 6? When you subtract them, you get 1, 3 and 2. So those are my factors. X plus 1, x plus 3, x minus 2. There's one. Do synthetic division with this one. Okay, before you go too far, just make sure you set it up correctly. So it's x to the fourth, x to the third, x squared, x, and constant. So what are the coefficients? 1, 0, negative 26, 0, 25. That's why when you start off with the highest exponent, you have to count down to get to the constant. And if there's nothing there, let's put a 0. That's why you have to be very, very careful when you do long or synthetic division. You have to make sure that each of those are taken care of. Bring down the first one. 5 times 1 is 5. 5 times 5 is 25. Negative 1. 5 times negative 1 is negative 5. Plus 0 is negative 5. 5 times negative 5 is negative 25. 0. So this is a factor. And what's left that we have to look at is x cubed, 5x squared, minus x, minus 5. Because that's your coefficient, that's your constant, your x squared, your x cubed. And we go from there. Make sense? So I threw that in there because I want to make sure that you put zeros in what's missing. All right, that does it for section 4.3. Now we're going to get into bigger equations. Do you have any more examples I want you to do? Yeah, we just those. Okay. 4.4. Theorems about zeros of polynomials. And this one here is where we're going to look at ways of finding much larger polynomials. So factoring those out. First, we have to look at the fundamental theorem of calculus, of algebra. Fundamental theorem of algebra. It says this. Every polynomial of degree n, where n is greater than 1, greater than or equal to 1, has at least one zero in the set of complex numbers. If you think about that, it's a very, very, very broad statement. What are complex numbers? What do complex numbers look like? We did that a week and a half ago. Complex numbers are this, where you have a real part and an imaginary part. So I mean, remember examples of these, 4 is a complex number. It's actually 4 plus 0i. 0 plus 2i is just 2i. That's a complex number. Or you can have 3 plus 5i. So any number can be written as a complex number. So you'll have at least one answer in every polynomial degrees greater than 1. What does that mean? What is an example of a polynomial of degree 1? Yeah, a linear equation. Because the degree is 1, it's a polynomial of degree 1. How many solutions does that have? 1. The solution here is wherever the x-intercept is. Now, what does that mean in the long scheme of things? So if we take any polynomial, let's make this p, it'll have some coefficient, and it can be factored out into smaller terms like this, bump, 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 all the way up to xcn. In other words, any polynomial, if it can be factored out, if it's degree n, it can have up to n factors. Make sense? Let's look at working backwards first. That's our goal, to get to that big part. If the zeros are 3 and 5, find the polynomial that has those zeros. So if these are zeros are 3 and 5, that means x equals 3 and x equals 5, right? Those are my x-intercepts. Let's work backwards. Let me show you what I mean by working backwards. If I give you, we're used to doing this. If I give you a polynomial and we factor it out, this becomes x plus 3, x plus 2. We set those equal to 0. So we have x equals -3 and x equals -2, right? That's how we do that. Now, I gave you these. You have to go this way. So you have, now your first step is make it equal to 0. How do you do that? Subtract 3 from both sides. Subtract 5 from both sides. So x minus 3 equals 0. X minus 5 equals 0. So if I give you the zeros, make them equal 0. Now put those two together. So I have x minus 3 times x minus 5. What do I do when we have these two? I multiply them. I get that. I get the polynomial. So x times x is x squared. Positive, negative is negative. X times 5 is 5x. Negative times positive is negative. 3 times x is 3x. Negative, negative is positive. 5 times 3 is 15. Combine like terms. So there's the polynomial where it came from. That's all we're doing is working backwards now. The more zeros we have, the bigger your equation is going to be. If we have 3 zeros, what kind of equation are we going to have? What's our degree going to be? 3, because the number of solutions is our number of degree. So we set those equal to x. Next step is what? Okay, after we go up.
X minus 2.
Right, make them all equal 0. So move them over. Make it equal 0. So x minus 2 equals 0. X plus 2 equals 0. X minus 5 equals 0. Then multiply them all together. Let's do these two. X times x is x squared. Positive, positive is positive. 2x. Negative, positive is negative. 2x. Negative, positive is negative. 2 times 2 is 4. Combine like terms. These two cancel. It's just this FOILing or distributing. X squared times x is x cubed. Positive times negative is negative. X squared times 5 is 5x squared. Negative times positive is negative. 4 times x is 4x. Negative times negative is positive. 4 times 5 is 20. There's my polynomial. Make sense? Let's see another way of writing these things. Because last time we talked about multiplicities. Zeros are 2 with multiplicity 2 and 3 with multiplicity 1. Find me the polynomial. So what does the first one mean? If the 0 is 2, so we have x equals 2. We solve that, we get x minus 2 equals 0. X minus 3 equals 0. Multiply them together, but where does the multiplicity come in? What is a multiplicity? The multiplicity is the exponent of your 0. Yeah, since the multiplicity is 2, on this 0, I have to put a 2, and that one is a 1. So what's our degree? Yeah, 2 plus 1 is 3. If you add up all your multiplicities, that's your degree. So we got to do x minus 2 times x minus 2 times x minus 3. Negative 2x, negative 2x, negative negative is a positive, 4. Combine like terms. Now what do? Everything in this parenthesis has to multiply everything in this one. X squared times x is x cubed. Positive times negative is negative. X squared times 3 is 3x squared. Negative times positive is negative. 4x times x is 4x squared. Negative times negative is positive. 4x times 3 is 12x. Positive times positive is positive. 4 times x. Positive times negative is negative. 4 times 3 is 12. Combine like terms. Negative 3, negative 4 is negative 7. Positive 12, positive 4 is positive 16. And there's your polynomial. What do y'all think? Pretty straightforward?
Mhm.
Okay, let's try it now with imaginary numbers. Because remember, it has to be complex numbers. They have to be complex numbers. So my zeros are 1, 3i, and negative 3i. Find me the polynomial. So we set them all equal to x, and then set them to 0. Then we multiply them all together. Multiply these two together first. I don't know if you remember when we did complex numbers, but when you multiply these together, what do you notice about these two binomials? Except the signs. They're conjugates of each other. And we learned when you multiply conjugates together, what happens? You're asking. Well, let's see then. Let's work it out. X times X is X squared. X times positive 3ix. Negative 3ix. Negative positive is negative. 3 times 3 is 9. I times I is I squared. 3ix cancel. I squared becomes what? What does I squared equal? -1. It changes the sign in front of it. Again, you guys have to review your notes, have access to them. Now we multiply. X times X squared is X cubed. Positive is positive. 9x. Negative positive is negative. 1 times X squared is negative X squared. Negative positive is negative. 1 times 9 is 9. Put them in decreasing order, and there's your answer. Here's a note. Whenever you deal with radical or imaginary numbers, they must have their conjugates. Whenever you deal with imaginary or radicals, you have to have their conjugates. You have to include their conjugates. For example, the zeros are -2 plus 5i, -2i, and 1 minus radical 3. Tell me, what is the degree of the polynomial? Well, we have 3 terms right there automatically. The degree is 6. Because if this is a 0, if x equals -2 plus 5i, I also have to have its conjugate. What's its conjugate? -2 minus 5i. If x equals -2i, its conjugate is +2i. If one of my x's is 1 minus radical 3, I have to have its conjugate, 1 plus radical 3. Whenever you have imaginaries or radicals, you have to have their conjugates. So now we have 6 terms, 6 parts. So it's a degree 6. You okay with that so far? So whenever your zeros are stated as being imaginary or radicals, you have to make sure that their conjugate is there before you go any further. Now we're talking about the rational zero theorem. What this thing says, let me just write the whole thing down. Let the polynomial an x to the power n plus a n minus 1 x to the power n minus 1 plus dot 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 a1 x1 plus a to the 0 is a polynomial. All coefficients are integers. Consider the rational number P over Q. It's small p, not capital P. Where P and Q are relatively the prime numbers, the prime factors. And they have nothing in common. If P over Q is a 0 of the polynomial, then little p is a factor of a sub 0, and little q is a factor of a to the sub n. Okay, that's mathematic talk. And I'll show you what it means in a second. Because so far, all of our examples that we did, those big equations, and if I asked you to find the factors, what was the leading coefficient was always what? Coefficient. The leading coefficient, look at your examples. The leading coefficient was always 1. Now, let's look at a polynomial where the leading coefficient is not 1. This is 11. Let me see how it is. 3x squared. That's 14x squared 3x cubed, 14x squared plus 14x minus 4. Okay. Everything I just told you there, remember I told you the P and Q and the factors of P and Q? The P in our equation, the P over Q, the P is the last number, is the constant. The Q is the leading coefficient. Because if you think about it, how many different ways, because now our answers may be fractions. So far in the last section, all of our factors were either x plus 1, x minus 1, x plus 2. Now we can have answers that are fractions. Our factors can be 2x plus 3. So what we have to do here is our last number is 4. Our first number is 3. We have to look at the plus or minus of each of these factored. What is 4? What can 4 break down into? Yeah, 1 times 4, 2 times 2, or 4 times 1. Those are the possible factors of 4. What are the possible factors of 3? 1 and 3. So now we have to look at all possible combinations. We have 3 on top, 2 on the bottom. So plus or minus 1 over plus or minus 1. Plus or minus 2 over plus or minus 1. I have to take each of these on top with each of these on the bottom. Plus or minus 4 over plus or minus 1. Now the other one. Plus or minus 1 over 3. Plus or minus 2 over 3. Plus or minus 4 over 3. I got tired of writing plus or minus all the time. So we take the last number and look at all the factors that it could be multiplied into. Take the first number and do those, and then look at all possible combinations. So in the first one, we have plus or minus 1 divided by 1 is 1. The second one, 2 divided by 1 is 2. 4 divided by 1 is 4. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. And then 4 divided by 3. What this has just done it has limited the number of numbers we have to check. Because earlier we have infinite. It can be positive, it can be negative, it can be all of them. But now 1, 2, 3, 4, 5, 6, we've narrowed down from infinity down to 12 possibilities. Our factors have to be one of these 12. So let's start with these. Do synthetic division. We do positive 1, negative 1. It's 3, negative 14, 14, negative 4. 3, negative 14, 14, negative 4. So this is called the rational zero theorem. I take the last number, factor it out, and take the bottom number, factor it out. All these possible combinations, answers have to be in there. We've limited from infinity down to these 12. So is it the first one? Is it 1? One times 3 is 3. Negative 14 plus 3 is negative 11. 1 times negative 11 is negative 11. 14 minus 11 is 3. 1 times 3 is 3, negative. So it's not 1. Negative 1 times 3 is negative 3. Negative 14, negative 3 is negative 17. Negative 1 times negative 17 is positive 17. 31. I'm going the wrong direction. So it's not either of those. So it's not these. So I try these two. Three, negative 14, 14, negative 4. So everybody see what I'm doing? So I just go through each one of these pairs of numbers and try to find the one that works. Of course, I do the integers first before I do the fractions. Because if it's a fraction, that's pain. So bring the first one down. 2 times 3 is 6. Negative 14 plus 6 is negative 8. 2 times negative 8 is negative 16. 14 minus 16 is negative 2. 2 times negative 2 is negative 4. Negative 8. So that's not right. Negative 2 times 3 is negative 6. Negative 14, negative 6 is negative 20. Oh my God. 20 times 2 is 40. 54. So 100, negative 108. So that's not going to be right. Let's try 4 and negative 4. Three, negative 14, 14, negative 4. Four times 13, or 4 times 3 is 12. Negative 14 plus 12 is negative 2. 4 times negative 2 is negative 8. 14 minus 8 is 6. 4 times 6 is 24. Negative 4 times 3 is negative 12. It's negative 26. This is going the wrong direction. It's negative 4 times negative 26 is positive 104. 118. So that's not going to work. Now we got to do the fractions. Damn. 1/3. Negative 1/3. 3, negative 14, 14, negative 4. One third times 3 is 1. Negative 14 plus 1 is negative 13. 1/3 times negative 13 is negative 13 over 3. So we have 14 over 1. But to multiply it by 3, so it's 42 over 3, so it's negative 40, or positive 42 over 3. 42 over 3 minus 13. 29 over 3. Yeah, it's not looking good, is it? 1/3 times 29 over 3 is 29 over 9. This is 4 over 1, so I've multiplied by 9. It's negative 36 over 9. 29 minus 39 minus 36 minus 29 is 7 over 9. Negative 7 over 9. That's not it. I didn't say it was gonna be easy. As I say, it's less work now. So negative 1/3 times 3 is negative 1. Negative 14, negative 1 is negative 15. Negative, negative is positive. 1/3 times 15 is 5. Because 15 divided by 3 is 5. 14 plus 5 is 19. 19 times negative 1/3 is negative 19 over 3. Now this is going to be 12 over 3, so it's going to be negative 31 over 3. So now we're at 2/3 and then 4/3. Two-thirds, negative 2/3. Three, negative 14, 14, negative 4. 3, negative 14, 14, negative 4. Two-thirds times 3 is 2. 2 over 3 times 3, the 3's cancel. So I have 2. Negative 14 plus 2 is negative 12. Negative 12 times 2/3. 3 goes into 12 4 times. Negative 4 times 2 is negative 8. 14 minus 8 is 6. 6 divided by 3 is 2. 2 times 2 is 4. 0. Yes, there's our first answer. Your cell phone is not going to have it. Those texting you're doing is just going to waste your time because you're not even listening now. So 2 over 3 is our, so x equals over 3 is our first answer. So that equals 0. So multiply both sides by 3 and subtract 2. So our first factor is that. Whatever's on the bottom goes in front and the opposite sign. So there's our first factor. Now we just have to look at these. 3x squared minus 12x plus 6. They all have a 3 in common. We can't factor it. So guess what? We got to use this. So what's A, what's B, and what's C? What's A? 1. B, -4. And C, 2. So negative of a -4. -4 squared. 4 times 1 times 2. 2 times 1. Negative is a positive. -4 squared, 4 times 4 is 16. 4 times 1 is 4, times 2 is 8. -8 is 8. Eight is 2 times 2 times 2. So there's a pair of 2's. 2 square root of 2. To factor out a 2 on the top. So my final answer, 2 plus or minus square root of 2. Those are the factors of my polynomial. Okay. So for these, I'm gonna put up a couple more examples. And then what I want you to do is tell me what are the rational zeros. Or is the, tell me the P over Q's. List them all out. Two x to the fifth minus x to the fourth. So tell me the rational zero, possible rational zeros. So it's P over Q. What's P? P is 5. And Q is 3. So what are the factors of 5?
35.
And 3. So the possible factors can be 1 over 1, 5 over 1, 1 over 3, 5 over 3. So these 2 over 1, these 2 over. So basically we have 1, 2, 3, 4 times 2. We broke it down to 8 possible answers. Originally it'd be infinity. Imagine doing the last one where it's a fraction. How many fractions would you have to go through if you didn't know what to do? Infinite number of them. And this one. P over Q. What's P? And what's Q? So the possible factors of 15. Yeah, 3 times 5 is 15. 1 times 15. So it's what two numbers multiply give you 15? 15 times 1 or 3 times 5? What equals 2? So we're going to have a possibility of 1, 2, 3, 4, 8 possibilities. 1 over 1, 3 over 1, 5 over 1, 15 over 1, 1 over 2, 3 over 2, 5 over 2, and 15 over 2. Of course, these are all plus or minus. So that's how this thing works. So what does the rational zero theorem tell us? It narrows down the possibilities of answers. We can go even further now. Descartes' rule of signs. Even though originally we had infinite possible choices, now the rational zeros tell us now that we can have a possibility of 8 plus or minus, so it's actually 16 possible answers to choose from. We can narrow that down even further with this. This one tells us the number of positive and negative answers we're going to have. Descartes' rule of sign breaks down further and tells us how many positives and negatives we can have. So here's what that means. Let's pretend we have a polynomial of 2x to the 5th minus 3x squared plus x plus 4. What this thing says is we're going to have at most 5 answers, because some of the answers could be multiplicities of each other. Number of positive answers. Look at our original equation. What you're looking for is the number of sign changes. So this one's positive, that's a negative. That's one sign change. From negative to positive, is that a sign change? Another sign change. Positive to positive? No. So we have 2 sign changes. Which means we can have either 2 or 0 positive answers. And I'll tell you why in a second, why it's 2 or 0. The number of negative solutions. Change the sign in front of each x that has an odd exponent. So we have, our original equation is this. So that's an odd exponent. So this sign changes. It becomes that. That's an even, so that one doesn't change. This one's odd, it only has one, so it changes. So if it has an odd exponent, change the sign in front of it, of the number instead of the coefficient. And do the same thing. Look at the number of sign changes. Negative to negative, nope. Negative to negative, nope. Negative to positive is 1. So for the number of negatives, we're going to have one negative solution. Why is that helpful? Because let's say our first answer was -1. Do we have to check any more of the negatives? No, we found our only negative answer we're going to have. Now we know we're going to have 2 or 0 positive answers, but we're missing 2 more. We're supposed to have 5 answers. We'll have at most 2 positive ones, 1 negative one. What about the last 2? The last 2 will be imaginary. Because imaginaries have to always travel in pairs, the conjugates. So we know we're going to have 1 negative answer, 2 positive answers, and 2 imaginary answers. So we have positive, negative, imaginaries. Because it has to equal 5. So we can have 2 of these, 1 of these, and 2 of those. What if we have 0 of these, 1 of these? Then we'll have 4 of those. Remember up here, I said we had 2 or 0. The reason I subtracted by 2 is because of the imaginary ones. They have to come in pairs. So that's what happened to it. Let's look at another example. And tell me here, this will be our last one, we'll call it a day. I want a bigger one. Oh, there it is. 5x to the 4th minus 3x cubed, 7x squared minus 12x plus 4. Positives, negatives, and imaginaries. So there's 1 change, 2 change, 3 change, 4 changes. So it's either 4, 2, or 0.
Wait, what?
We only have 4 sign changes. So we have at most 4 positive answers. But if 2 of them are imaginary, then we only have two of those. So 4 of them could be imaginary, we'll have no positive ones. How about the negatives? So that sign doesn't change. This is an odd, so that changes to a positive. That one doesn't change. That's an odd, so that changes. How many sign changes here? 0, so there's no negative answers. So what does that do? We don't have to worry about the negatives. You know, plus or minus and the rational ones. We have no negatives, so we haven't to worry about those. So we just cut our answers in half. So we're either going to have, if we have 4 positives, we'll have no imaginaries. If we have 2 positives, we'll have 2 imaginaries. So that's how it works. So that's what the Descartes rule of science tells us. Descartes is the same guy who invented that Cartesian coordinate systems, the XY chart. All right, that does it for this much of chapter 14. We only have one more section left, or two more sections left. Rationals and inequalities.